Thank you. My name is Peter. I've been with Secomere from the very beginning. As announced, I will talk about remote maintenance and more specifically remote access and the associated security concerns. The following presentation will silently be divided into two sections. One, setting the scene by showing the Secomere angle to remote access and what it's typically used for. This leads into second part, which is the industry's view on remote access today and tomorrow, which naturally starts a whole discussion about cybersecurity and especially the IEC 62443 standard. Secomere has made a strong market presence within secure industrial communication with specific focus on OEMs. Secomere is known in the industry for providing the best industrial remote access solution, which has led to some interesting global partnerships. One that we are particularly proud of is our strategic partnership with the world's largest producer of IPCs. Combining the best remote access solution with the best industrial hardware solutions simply seems like an obvious synergy match. Although also supporting data collection and monitoring, the Secomere solution is specifically designed for remote maintenance, and with a particular focus on remote access for purpose of programming, troubleshooting, calibrating PLCs, HMIs, etc. This is what we refer to as corrective maintenance, which involves secure, real-time, end-to-end remote access capabilities. Some will refer this as tunneling access to the endpoint. The solution consists of basically three components. A client then for engineers to log in and gain access to a specific device using his favorite software. An industrial gateway at the remote location, which can be in form of hardware, device, or software on a suited platform, such as the Advantech you know. But most importantly, a central server that handles authentication, authorization, and acts as a communication hub, while also assuring fleet management of all equipment involved in the solution. By design, the Secomere agent concept allows you to define fine-grained access. For instance, one remote user can access a PLC for programming, while another can only access its web interface. The entire setup is highly customizable. You can make specific accounts for external personnel, and with the domain organization, you can control exactly what they see, and you can make accounts that expire on a certain date, only have access to one machine or facility, have access on a specific day or hours, or even after the user has logged in once. Access can also be quickly changed using the drag and drop functionality and familiar folder structure. Remote solutions such as that of Secomere are expected to cover the lifetime cycle of a machine, consisting of commissioning, which involves installation, calibration, and operator education. And this is followed by the machine going into production. And then data from everyday operations is then used to consider potential optimizations. It's all about productivity. When addressing the concerns of each phase of this life cycle, we like to break up the various categories of maintenance efforts into three areas. The type of maintenance that address all part of the cycle is called corrective maintenance. It's a specialty that Secomere has become market leader in. Preventive maintenance is used to ensure uptime by handling consumables and spare parts, as well as operator efficiency. Lastly, the predictive element uses the trend and analysis data from daily operations to increase uptime by optimizing machine utilization and predicting wear and tear. We'll look at a generic example that illustrates the different maintenance scenario. This factory or facility has a typical production machine with mechanics, sensors, PLCs, and an operator panel. However, these same actions and responses could apply to a variety of cases such as mobile equipment or building automation. In this context, the machine provider is actively involved in maintaining the machine with a service agreement. The access is facilitated by an IoT edge gateway feeding data to a cloud-based machine-to-machine server. Production issues are captured and alerts can be sent to the on-site operator. In case the operator cannot immediately fix the issue, they contact the machine provider's help desk, who then go online and the operator's HMI via VNC. This is a gray zone between preventive and corrective maintenance. But real corrective maintenance is when the help desk cannot fully resolve things and the case is escalated to engineering, where a specialist remotely enters the PLC to further troubleshoot. For hands-on assistance, the operator can be instructed on next steps and eliminate the need for the engineer to travel on site. Lastly, the collected data can be used to identify trends to optimize the machine, that is, for predictive maintenance. A real-life corrective maintenance case. Haas Meinke, one of the world's largest manufacturers of baking equipment, uses Secomea solution to service their machines worldwide from the headquarters in Denmark. This reduces technicians' travel costs and ensures customers increased uptime. They've done this for the last 10 years and every machine is shipped with a Secomea gateway installed. Another real-life case illustrating preventive maintenance with potential of predictive maintenance. Formaco is the world's leading manufacturer of curing and marinating equipment for the food industry. They are essentially offering the tracking of consumables, wear and tear, trends, etc. as an OEE service to their customers. Their customers could certainly set this up on their own with SCADA and gathering data and do these calculations, but Formaco really knows the machine best and can set this up and hook up the right sensors and information prior to delivering the machine to their customer. They provide a customized cloud portal for the customer, and this is an added value to their purchase. But let's jump back to the corrective maintenance and let's look at the general situation for remote access. In July, PMMI, the Association for Packaging and Processing Technologies, announced an interesting report which you can also find online at the pmmi.org. Remote access was, of course, mentioned in relation to Industry 4.0. And it was clear that security is a concern here, emphasized by some of the quotes, some related to safety and some related to security. But more interesting is the finding that the comfort using remote access has actually increased, despite of the increasing safety and cybersecurity concerns. The manufacturer's comfort of allowing remote access has increased from 32% to 58% in the last 3 years. The PMMI report takes offset in Industry 4.0, which is not really a standard, but a framework for digitalization. For industrial control systems, the main topics are safety and security. With regards to safety, the concern about remote access is what a remote service engineer can do on the machine that will endanger the operator. For instance, starting and stopping the machine while the operator is physically handling it. Think of a robot that suddenly starts and pulls off the head of the operator. The prevention mechanisms in a remote access solution would typically be to assure that a remote access can only be performed when the operator allows it, either via an input port or simply physical on-off switch or a digitally controlled remote access time slot. Typical for safety is that it only has to be evaluated once. Once you have done a risk assessment, then it's safe. For security, however, the assessment has to be done over and over as vulnerabilities will appear. Here we're looking at two relevant standards. ISO 27000 that only covers the IT side and is not specific to products, but more the IT processes and not the OT side. Typically, you would look at this when hosting services for customers, and that this could be covered by also a ISAE 3402 service assurance audit. IEC 62443, however, is specific for automation and the production, i.e. the OT side. With regards to IEC 62443, it's not just one standard. There are several of them addressing different topics, and within some of them you also find different compliance levels. At the bottom here is the component layer, and the 4-2 standard covers the product which the Sigomera solution is subject for, in combination with 3-3. For Sigomera products, the compliance audit is performed by the German company Protectum. Protectum performs regular audits of Sigomera releases with reference to the IEC 62443 standard, and have further combined it with assessment against NIST and BSI standards. In fact, Protectum has also performed an audit of the Sigomera solution against Industry 4.0. Although this is not a standard, but rather a framework, it was important for Sigomera to validate if we could match the expectations of Industry 4.0's smart factory vision. That includes a multidimensional communication relationship involving machine suppliers, raw material suppliers, service partners, and the factory itself, who all need to be authenticated and authorized individually and have individual and isolated access to specific equipment and data. The conclusion was that the Sigomera solution, by its role management and domain hierarchy structure, is an ideal communication broker in an Industry 4.0 context. Components and systems auditing are based on outside views, which does not warrant that they are based on solid processes. 4-1 is the standard specific to processes where you assess design and maintenance procedures, and a part of this is how you handle vulnerabilities. Just as ISO 9001 is a clear demand of a manufacturer today, we believe certified SDLA compliance will become mandatory in a few years. Sigomera is working towards an official SDLA certification in 2021. As mentioned, a part of an SDLA process and what Sigomera is already applying today is procedures for CVE handling. CVE stands for Common Vulnerability and Exposures. The larger the company and the more widespread a product is, the more vulnerabilities will be discovered. It's no shame to have vulnerabilities, but it's a shame not to fix them when notified, and proactively inform about them, that is, have processes in place. As seen here, Sigomera, Advantech, Siemens and others are and will be subject for vulnerabilities. I'm normally not keen on just reading slide bullets out loud, but in this case I'll do it to emphasize my point. The business value of a solution must be emphasized to outbalance the security implications. Talk value, not functionality. There will be pushback from IT, always. Don't fight it, but understand their concerns. Traditionally, OT's primary responsibilities were safety and reliability, but increasingly also cybersecurity. Remember to balance it. Established security audit reports may not be enough. Larger companies will perform their own pen test, take them seriously, and engage the vendors, such as Sigomera. OEMs will be less able to dictate a remote access solution. The manufacturing side's OT, IT will need to concur and may well reject it if they are uncomfortable. Get in dialogue with the end customer.